Hello everyone, welcome to your tutors. This is Mrs. Tole. So today we're going to look into functions, and with functions, this is the linear functions. This is the first class of functions in grade 10. And what we're going to look into today, you're going to leave this class knowing the general equation of the linear function, knowing the effects of A, knowing the effects of Q, knowing how to calculate the gradient, and also sketching and finding the equation of a straight line. Okay, so now let's dig in and see what we have today. But what I like doing, I like to start with questions so that you guys can try to do these questions. If you don't understand these questions, you know that this class is for you. And by the time the class ends, you need to come back and attempt these questions. Okay, now let's start with knowing the general equation. So general equation for linear function, it's y is equals to ax plus what called q. Okay, so y is equals ax plus q. What is our a? Our a is actually the gradient. Okay, is the gradient, and the gradient we're just referring to the steepness of what is it of the line. So this actually refers to the steepness. Okay, then what about q? When you look at q is actually what is it? The y-intercept. So given that coefficient of y is 1, it means that the value, where the graph crosses the y-axis is actually the q. So this y-intercept means that where graph cuts the y-axis. So cut y-axis. Okay, that's what we mean by the y-intercept. Okay, now let's get back to the equation. So we need to know the mother graph. The mother graph in this case is y is equal to x, and that's the one that we can determine using this table that we have here. So now with this mother graph, what we can do is that we can we can have the other graph here, which is actually y is equal to, so let's just put it, y is equals to 2x, and here is y is equal to sorry about that. Okay, this one here, it's y is equal to okay, so this is y is equals to half x. Okay, 1 over 2x. So what happens now is that we want to see how the how the gradient affect the line. So when a is half, it's below 1, it's a fraction, it means that not below 1, between what called, if a is between 1 and 0 and 1, so in this case it will be 0 less than a less than 1, it means that this one here is less steep. But if a is greater than 1, like what we have here, a is 2, it means that this is steeper. So, and we are referring to we are comparing with the mother graph. This one here is actually the mother graph. So anything that we do, we are transforming from y is equal to x. So if we are to put anything above what call 1, it means that their graph is going to be on top of the y is equal to x. And if it's going to be a fraction, it's going to be below what is it, y is equal to x. And you can see that these lines are, this one is here, is less steep than what call this one here. Now, what about this side here? We can also see that we have also the lines here, which is y. In this case here, it's y equal to negative x. And this is a reflection in the x-axis. It's a reflection of y is equal to x along the x-axis. So this one here is a reflection. Now, what we understand now is that when a is negative, it's a reflection. So once you see a negative, that know that it's a reflection, what called to the mother graph. Okay, that's what we know. Now, what about here? We can also refer to this one as we can see it's cutting. Okay, this is y is equals to negative 3x. So you can see that when a is also above negative 1, what we see is that it's gonna be it's below -1. Sorry, it's below -1. It means that in this case here, it's gonna be steeper than the y is equals to -x. Then here it's gonna be y is equals to -1 over 3x. So if we are asked to sketch this, what you need to understand is that you have your mother graph to start with, and whenever your value is between 1, is above 1, then you know that it's going to be more steep. If it's below 1, you know that it's going to be less steep. Okay, now, then we also talk of what we call domain and range. I'm going to put range here. Okay, now domain is, these are input values. Okay, input or set of x values. So these are x values, and when it comes to range, these are y values. So the set of y values. Okay, so, and when you are talking of input and output, these are input values. Okay, input values, these are output values. Okay, so what we are saying is that, like from the graph from this table that you see, this actually refers to the domain. These values are your part of your domain, and this is part of your range. So we can just say here it's going to be your D there. In this one, it's going to be your range there. So now what happens now is that when we're talking of a range, we are saying a domain set of x that can be what we call approached or occupied by the graph of y is equals to x, or a linear function. So linear function is a straight line. It does not have any asymptote either on the x or what we call on the y. So what we understand is that domain is always from -infinity. Okay, sorry about that. So here domain is x set of -infinity to +infinity. Okay, that's what it means. Or we can just say x element of real numbers. So it can occupy any value. Then again, also, when it comes to the range, also, y also is element of what we call -infinity. It can occupy any value from down here up until down up there, without any what we call a problem. So here is actually from +infinity to -infinity to +infinity. We can also say y element of real numbers. Okay, so it can occupy any value. That's what you need. So for linear functions, no stress. Domain x element of real numbers. Range y element of also real numbers, unless if it's specified. For example, in this case here, on this graph here that we have, if you had only to draw from -1 to 1, our domain in this case will be x. So it's gonna be so it's gonna be -1 less than x less than or equal there, or equal to 1. What about also the range? The range is going to be the same thing, because we will be guided with these values. Okay, now let's move on to the next slide here. Now, when I look at effects of Q now, how does Q affect the graphs? So what happens? Q is a shift, vertical shift. We know that that's y-intercept. Yes, it's y-intercept. But what I forgot to tell you there is that it's a vertical, this up and down shift. We can call it vertical shift. So this is up and down. So you can either take your graph up or down. Which graph are you taking? You are taking the mother graph. You're taking the mother graph. So for example, here, this is our y equal to. So this is y equal to x. And what we see that this graph, we have taken this graph, we've lowered it up until to the -4. So we've shifted it downwards. So it was shifted downwards by 4 units. So what happens now is going to be y is going to be equals to x plus minus 4. And in this case here, what call it's y is equals to x plus 5. So in this case, there was a shift. So shift of y equal to x by 5 units up. Then here it's a shift of y equal to x by 4 units down. So that's what we have. So that's your graph. So this q is just the q is just representing the shift up and down. So whenever you see any value there, you know that your graph is going to cut in the y-axis, is going to cut at that particular value. That's all what you need to understand there. Okay, now let's move on. Now let's move on to the gradient part. Now I want to talk of the gradient, and whenever you talk of gradient, when you see this kind of line going up, it's going uphill, and when it's going uphill, we call that it's increasing gradient, because it's going uphill. Okay, it's going uphill. What about this idea is downhill? So downhill, so you just say uphill is increasing, and here is going downhill, and it's decreasing. So when I talk of set of values where the what called the graph is decreasing, you know that that's where it's having negative gradient. When it's saying increasing, that's where it's going to have what called positive gradient. That's all. So with increasing, we know that the gradient is positive, okay, and with decreasing, the gradient is negative. That's what it means. So whenever we talk of increasing, it's a positive gradient. What is it? When we talk of decreasing, it's a negative what called gradient. Okay. Now let's see how do we find gradient. So you can get gradient from the from the equation. So gradient from the equation, let's have an equation like what we have here. Gradient of this, how do you get the gradient of this one here? It's y is equals to 2x plus 11. So gradient is your 2. That's your gradient. So gradient, our A in this case is going to 2. We are just picking it from the graph, from the equation. No need for calculations because you know where it's positioned. But now let's say you are given an equation that is let's say it's 4x minus or let's say 6x minus 3y is equals to 9. Okay, so 6x minus 3y is equal to 9. How do you get the gradient? So this is scenario 1. Scenario 2, what you need to do here, first of all, make y subject. So you make y subject to the formula first before you do anything. Make y subject to the formula. Now, what do you do now? You're going to take 3x, that side is going to be, let's just simplify this quickly. So it's going to be negative 3y. It's going to be because 9 minus 6x. And in this case, we divide by negative 3 by negative 3 by negative 3. Okay, so here is what we get. Y is going to be equals to what called negative 3 minus, it's going to be plus there, plus 2x. And in this case here, we can see that the equation in this case will be, the gradient in this case will be will be 2. So that's our gradient there. So A is equals to 2. That's what we do. So because we know that A, the gradient is coefficient of coefficient of x. That's what we know. Coefficient of x, that's what we know. Okay, so I think in other cases you're going to see your equation as y is equals to mx plus c. Don't stress. It's still meaning the same thing. That's your C is your Q, your M is your A that we're dealing with. So there is nothing to worry much about there. Okay. Now let's move on the calculations of what you call given coordinates. Now, given coordinates. How do we get how do we get gradient? So we know that M or A here, let's use A is equals to y2 minus y1 over x2 minus x1. Okay, so here y2 minus y1, x2 minus x1, you only getting this from your coordinates. So coordinates will be in this case here. What is it? Coordinates start with x, so it's gonna be x, maybe x2, y2. Then you have another coordinate there, x1 and y1. Okay, so those are the coordinates that you'll be dealing with in this case. So for example, let's deal with what called graph, what is it? This line here, which is what you call CD. So for CD, what we have here is gonna be, we have got XC and XD. So we've got coordinates here, coordinates of -2, -5. Then you also have what you call 6 and 13. Okay, those are the codes that we're dealing with in this case. So how do we get the gradient? Gradient, we're going to take the value of y there is going to be -5 minus 13, okay, over -6, -2, sorry, in that case, -2 minus 6. Okay, so let's try to see what we get there. But here, if we're going to say, let's just, I think it's going to be easy for us here. -5 negative is going to be -18. Okay, then negative, what is it? -2, -6 is going to be -8. Okay, then that's what's going to be our value there, which is going to be equal to 18 over 8 divided by 8. We get 9 over 4. So our gradient there is 9 over 4. That's what we have there. So we can see how we get the gradient given the points, given the equation. That's how you get your gradient. Okay. Now let's talk of parallel lines and perpendicular lines. Okay, so when we talk of parallel lines have got the same gradient. So parallel lines have got equal gradients. Parallel lines have equal gradients. That's what we know. So parallel lines have got equal gradients. But what about, so we can just say M1 is equals to M2 for the gradient, or A1 is equals to A2, okay? But what about perpendicular lines? Perpendicular lines, when you multiply the gradients, you get -1. When you multiply the gradients, you get -1. That's what happens. So in this case here, we can take off AB. AB gradient is equal to 2. What about CD? Let's just quickly find the gradient of CD now. CD is going to be equals to, A is going to be equals to y2 minus y1 over x2 minus x1, which is going to be equal to 13 minus 5 over 6 minus 3, which is going to give us 18 over 9, which is going to give us 2. So we see also that gradient of CD is 2, gradient of AB is also 2. So therefore, we can simply say AB is parallel to CD. Why? Because the gradient A CD is equals to AB. That's what we have there. What about when it comes to the gradient of EF? Let's look for gradient of EF. So let's just say AEF there. How do you get gradient of AEF? We know that y2 minus y1 is equals to x 2 minus x1, and what do we get there? We're going to take 1 minus 7, okay, over negative 12 minus 4, and what do we get there? 1 plus 7 is going to be 8, okay, minus 12 minus is going to be negative 16, which is going to be equals to negative 1 over 2, okay. So now gradient of this one here is going to be negative half. So if we are to say gradient of AB, so if we are to say AB times the gradient of A, what we call AEF, this is going to be 2 times 1 over negative 1 over 2, which is going to give us negative 1. We're going to give us negative 1. So that's what matters here. That's what matters. So when you're talking of perpendicular lines, they meet at 90. That's what it means. They meet at 90. So it means that M1, M2 is going to be equal to negative 1. Or you can say A1, A2 is going to give us negative 1. So these are gradients. So if you take their gradients, you multiply them, you get negative 1. That's what you need to understand from there. Okay, that's all when it comes to parallel lines or what you call perpendicular lines. So whenever you're asked to find to determine the what you call to find to prove that lines are parallel, it means that you're just looking for their what is it, their gradients, then you equate their the gradient as equal, you know that they're parallel. If you are asked to prove that the lines are perpendicular, you look for their gradients again, you actually multiply them, and if you get negative 1, they are perpendicular. That's all what you do when proving those two things. Okay, now let's move on to the next here. Let's just increase our brightness there. Okay, now let's talk of equations now. Equations of lines. Okay, equations of lines. I'm just going to change here. It's fine. Now, equations of lines. How do you determine the equation of a straight line? Okay, that's what number one that you need to understand. How do we determine that? So first thing that you need to do is find a gradient. You find the gradient. Now, after finding the gradient, our gradient it's our A. Then after that, you use the equation y minus y1 is equals to A x minus x1. So in other cases, you're going to see that this can be M. This also can be represented as M, by representing our gradient. Okay, so don't even worry about that because it's the same thing. Now, so it means that our coordinate here, this x1 and y1 is just representing one coordinate. So x1 and y1 in this case representing a coordinate. That's all what you need to do. So remember, gradient first, then for the rest you come. So now for this one here, let's look for the equation of CD. So let's start by calculating the gradient. Gradient, we know it already. ACD is going to be equals to our gradient there is equal to 2. We already know the gradient. So how now do we get the, what is it? We're going to use choose any. We're going to choose any of the coordinates here. Let's just choose the challenging one, which is -3 and -5. -3 and -5. Okay, so let's write our equation now. It's going to be y minus y1 is equals to A x minus x1, okay, which is going to be equals to y minus y1 here is -5, okay, is going to be equals to 2 x minus x1, which is -3, okay, so it's going to be y plus 5 is going to be equals to 2 in a bracket x plus 3. Then here we take y plus 5 is going to be equals to 2x plus 6. Then here y is going to be equals to 2x. What is it? 6 minus 5 is going to be plus 1. Okay, so that's what we have as the equation. Let's say we use 6 and 13. Let's just want to prove to you that you can still get the same thing. Okay, now let's use 6 and 13. So here we're gonna use our a is equals to 2. Then here we use 6 and 13. So let's have our equation again. Y minus 13 is equals to 2x minus 6. Okay, then here y minus 13 is equals to 2x plus minus 12. Okay, now let's take our 13, that's going to be positive. Y is going to be equals to 2x. 12 minus 12 plus 13 is going to be plus 1. Okay, so that's what you need to understand, guys. So I hope you understand how we determine the equation of a linear function. Okay, now let's move on to the next one, which is your sketching of the graph. Now, what do you need to do when you're sketching? Sketching, you need to get your x and y intercept. Using what called dual intercept method. Once you're done with that, you connect the 2 points. That's it. You are good to go. You are good to submit your paper. Okay. Now let's look at this. How do we do that? Let's look for the x-intercept in this case. Let's start with the x-intercept. X-intercept. Y should be equals to 0. So here we put 0 as on h of x. 0 is going to be equals to 2 minus 2x. We take the 2 there. Minus 2 is going to be equals to negative 2x. Then we divide by negative 2 by negative 2. X is going to be equals to 1. So we get the 1. So it means that the coordinate in this case here is 1 and 0. That's the x-intercept. Okay. Now what about the y-intercept? Y-intercept. Our x should be 0. Okay, now what do? We're gonna say y is gonna be equals to 2 minus 2 0, which is gonna just give us 2. But remember again, we actually indicated to you guys that this here is your y-intercept, is your q. Okay, it's your q. So there's no even need to do this, but just for the sake of calculations. Okay, now let's do it. Now let's try to sketch. So when you're sketching here, we need to indicate the origin. You indicate the y-axis, then also the x-axis. Then from there, you have your points there. In this case, the point here is actually 0 and 2. So let's look for this. What is it? The coordinates here. We can just put here is going to be 1 and 0. Then here in this one here is going to be what you call 0 and 2. Okay, so how do we do it? We're just gonna put our straight line like that. So that we label it, y is equals to what is it? 2 minus 2x. That's how we determine that's how you sketch the graph of a linear function. What about here in this case here? We do the same thing, x-intercept. Y is equal to 0. We put 2x is going to be equals to, what is it, 6. Then here, because if we put 0 there, it's going to be 0 everything. Then it means that here we're going to say 2, our x is equals to 3. What about what you call y-intercept? X is equals to 0. Now, when x is equal to 0, we put 0 there. Negative 3y is going to be equals to 6. We divide by negative 3 by negative 3. We cancel that. Y is going to be equals to negative 2. Okay, so our coordinate in this case is going to be 3 and 0. And in this case, it's going to be 0 and negative 2. So we come down here. We draw we draw our sketch. Remember, this is just a sketch. And on the sketch, you don't need to write 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1. There's no need for that. What you just need to indicate is just show us the coordinates, the intercepts. That's all. That's all what we want. Okay. Now here we have got 3. Here we have got what? We have got a negative 2. So it's 0 and negative 2 there. And this is 3 and 0. Then you come here, you plot your graph. Make sure that you are using a ruler there. use a ruler. Use a ruler, please, to what you call, to connect your graph. Your graph. Y is equals to no. Let me not write something that is not there. This equation here is 2x minus 3. Y is equal to 6. Then you label your graph. So guys, this is the what you call, this is all about linear functions, grade 10. This is the introduction to what you call functions. I hope you enjoyed the class. Remember guys, don't forget to subscribe to our YouTube channel and follow us on Instagram and YouTube and also TikTok, Tatenda Story. Okay, thank you so much. Bye-bye.